Write some questions from the previous class. Write major products for the following. Now, write first question. I hope you guys remember what is the procedure to write these products. Okay. I'm giving you guys 5 minutes. Do it quickly. Once you're done, you will send the answers on my WhatsApp. Mariam. First answer is wrong, Mariam. Then second answer is correct. Third answer is also correct. Fourth answer is wrong. You have not identified the fourth. Mariam, please listen very carefully. In the fourth question, you have not identified the alpha carbon correctly. Identify the alpha carbon correctly. And in the first question also, you have not identified the alpha carbon correctly. Rabah, first answer is correct. Second answer is also correct. Third answer is also correct. Fourth answer is wrong. You did not identify the alpha and beta. That's why you're having a difficulty. Hafsa, looking at your answer. First is correct. Second is correct. Third is wrong. Fourth is also wrong. Please reread the rule. Where to add double bond with which beta carbon, with more hydrogen or less hydrogen. Hafsa, understood your mistake? Yes or no? Please tell me. Hafsa, understood your mistake?
Yes, sir.
Okay. Rabah, understood your mistake? Rabah, understood your mistake?
Yes,
sorry, yes, no. You see alpha and beta, and Hafsa, you will send the answer. Send it quickly. Mariam Khatun, you understood your mistake? Yes, Mariam? I can't hear you. Tell you 5 minutes are over. So here we will first of all identify bromine is attached to this carbon. So this will be alpha carbon. And after alpha, we have beta carbon. This is beta carbon. Now we have only one beta. So there is only one option. We'll make everything apart from the halogen atom and make a double bond between alpha and beta. In this part, we have alpha here and the beta is this beta. And this is beta 1 and we will call this beta 2. Now both beta 1 and beta 2, they have 3 hydrogens. That is why both of them are same. We can make the double bond anywhere. So I will make double bond here. Now when I look at this particular carbon, this is alpha because iodine is attached to this alpha, this carbon atom. This will be alpha. Now this is beta 1. Let us suppose this is beta 2. Beta 2 has 2 hydrogens. Beta 1 has 3 hydrogens. So beta 2 has less number of hydrogens. That is why I will make bond with beta 2, not beta 1. Hafsa, you correct this mistake. Okay. Now again, we will first of all look at the alpha carbon. So this is the alpha carbon directly attached to the bromine atom. Halogen atom, this is alpha. This is beta 1 and this is beta 2. Now beta 1 has 1 hydrogen and beta 2 has 2 hydrogens. So we are going to make bond between alpha and that beta which is having less number of carbon atoms. So we'll make everything apart from the bromine, then make a double bond between alpha and beta. And which beta? Which is having less number of hydrogen atoms. Write this quickly. Hafsa, send your answers. Hafsa, send your the answer हमने लिख दिया, खैर छोड़िए. Revise, guys. You guys are not revising. Okay, this is this is approximately last class. Tomorrow will be the last class complete. Okay. And if you're still making mistakes, you're not writing alpha and beta, and if you're not remembering the rules, and if you don't remember the rules, then you have to look at the rule. Okay. If you don't remember it. Write this down quickly. Now, moving on. Right, topic reactions with metal. When I say 5 minutes, you have to take into consideration 5 minutes. I'm not going to give any extra time. Okay, now reactions with metal. First, right, number 1, reaction with magnesium. Reaction with magnesium. Now, when reaction with magnesium happens, please remember all of these reactions will be happening with haloalkane. So, what is haloalkane? Haloalkane is R bonded with halogen. And if I react this with magnesium, I will get R MgX. So magnesium does the insertion reaction. It does the insertion reaction and it forms a bond between halogen and the alkyl group. And this is known as Grignard reagent. This class of compound, this R can be anything. So whatever the R is, for example, if it is CH3, it will be methyl. If it is CH2H5, that means 2 carbon, ethyl. If it is a benzene ring, it will be phenyl. So general name for this is alkyl magnesium. Now this X is halide. If it is chlorine, it will be chloride, bromine, bromide, iodine, iodide. Alkyl magnesium halide. Please read the statement. When alkyl halide is treated with Mg in the presence of dry ether, then they form a compound with formula RMgX called Grignard reagent. The importance of Grignard reagent is, please listen very carefully, drop your pens, leave your pen aside and listen to me very carefully. If I look at alkyl halide, then in alkyl halide we have carbon atom and halogen atom. Halogen atom, since it is more electronegative, it will be pulling electrons from carbon atom and making the carbon delta positive. There will be partial negative charge on the halogen atom. So this is what delta positive and delta negative. But when you look at Grignard reagent, please listen very carefully. Here the carbon atom is bonded with a metal. Metal have a tendency to lose electron. Metal has a tendency to lose electron. For example, sodium, it will lose electron, become sodium positive. Calcium, calcium 2 positive. Magnesium, magnesium 2 positive. Potassium, potassium positive. So since they have a tendency to lose electron, they will give electron towards carbon atom, making the carbon delta negative. So the important point here is we are reversing the polarity of carbon atom. Carbon atom, which was delta positive in alkyl halide, it is delta negative in Grignard reagent. Okay. Now, next point that you are going to write, this is alkyl halide. You write here some examples. For example, if you have ethyl bromide and you react this with magnesium in the presence of De. What is De? De is a short form that I write. You are not going to write. You will write dry ether only because you have to give exam. And the board people, CBSE, they don't know what is De. So what is De? De is dry ether. In the presence of dry ether, you are going to get Mg here and Br. So Mg will do a insertion reaction and you will get MgBr. Similarly, if you have chlorine here, then with Mg in the presence of De, you will get, instead of Cl, you will have MgCl. If you have benzene ring, that means haloarine, you add Mg, you'll get MgBr. This will be named as ethyl magnesium bromide. Now this is isopropyl group, so this will be isopropyl magnesium chloride. This will be named as phenyl magnesium bromide. After this, you will write a note, important note. Grignard reagent, GR Grignard reagent, GR Grignard reagent is very reactive. Is very reactive, due to which it can even react with moisture, and form alkene. Therefore, it is always prepared. In an hydrous condition. There's a direct question in NCERT. Why is Grignard reagent prepared in anhydrous condition? उसका answer यहाँ पे है ना. So see the reaction what is going to happen. Please listen. For example, if you have RX, you treat this with Mg, and you will get RMg X. Now let us suppose there is some water. Wherever you are doing the reaction, there is some water. So when this will be treated with water, when you will have water here, please look at the reaction that is going to happen. Now water is what? Water is HOH. Water is HOH. The hydrogen will be having delta positive because both of the hydrogens are attached with oxygen, which is more electronegative. And the carbon atom here, it will be having delta negative. So the carbon atom can easily attack on the hydrogen atom, right? And when R attacks on hydrogen, it will get RH plus MgXOH. MgXOH. Now let us suppose we have CH3CH2, CH3CH2Br. We treat this with Mg. We will get CH3, CH2, MgBr. Then we treat this with, not treat this, but let us suppose there is water around, there is moisture. Then please listen, this carbon atom will have delta or negative charge because this carbon is attached with Mg. The carbon which is attached with Mg, that will get a negative charge, and this carbon atom can easily attack on the hydrogen atom, and it will become CH3 carbon. Now previously we had 2 hydrogen, now it will become 3 hydrogen. So this is what now? CH3, it is ethane. So that is why it forms, and RH will be in general alkene. So what does it form? Alkene in the presence of water. That is why we use dry ether. When I say dry ether does not mean that it is gas or it is solid. Dry ether means absence of water. In chemistry, dry means absence of water. Write this down. Let me know once you're done. And plus you will get thank you, Hafsa, very much. Hafsa, you sent the answer. Thank you. Hafsa, you understood your mistake, right? What you were doing wrong?
Yes, sir.
Very good. Everyone done? Yes or no? Please tell me. All of you done?
Yes, sir.
Right, next, reaction with sodium. In reaction with sodium, we are going to look at three reactions. First, we will look at Wood's reaction. Second, we will look at Pvt reaction. Third, we will look at
Sir,
the
these
mixture.
all are within reaction with metals.
Yeah. Reaction in reaction with metals, we have reaction with sodium. Sodium is a metal, right? And inside
Yes, sir.
the reaction with sodium, we have three reactions: Wood's reaction, Pvt reaction, and Wood's Pvt. Wood's Pvt reaction. Right, number A. Wood's reaction. That in this, when two same haloalkane reacts with sodium, in the presence of dry ether, again we are taking dry ether because sodium, if water will be present, sodium will react with water. Okay, that is why we are taking dry ether. Dry ether is just a solvent. It does not do anything in the reactor. They form alkene containing double the number of carbon atoms. So the reaction is haloalkene plus sodium, haloalkene plus sodium. It is going to give you R bonded to R plus NaX. Basically, when we take two same haloalkene, that means in the reaction, what happens? Two of these molecules are reacting. Very easy to understand. Okay, please see what you have to do. How to make a product? You have one haloalkane like this. You just put another haloalkane like this, and these two will make bond RR, and then you will get इसी तरह का एक और होगा यहाँ पे, and you will get NaX, sodium X. One more sodium will be applied, and यहाँ से आपको ऐसे मिल जाएगा और यहाँ से ऐसे मिल जाएगा, and RR के पीछे बॉन्ड आ जाएगा. There will be a bond between RR, NaX, and NaX will be formed. So you'll get 2 NaX. Okay, so 2 and 3 doesn't matter. You have to understand this part more importantly. This part here. R and R will form bond. R and R will form bond. For example, if you have CH3 attached to bromine plus Na, they will give you only this much. Okay, they will give you only this much, and they will maybe write dry ether. What you need to do is, what is the product? You will make same thing CH3 with Br and make a bond between CH3 CH3. So क्या मिल गया आपको? You got CH3 bonded to CH3 plus NaBr. NaBr is not important. CH3 CH3 is more important. If you make CH3 CH3, you will get full marks. If you write NaBr, you will get 0 marks. Okay, please understand. If you write CH3 CH3, you are going to get full marks. But if you write only sodium bromide, you will get 0 marks. So try to understand the importance of both the products. This is more important. So focus here, not on sodium bromide. If you don't remember sodium bromide, no matter. It doesn't even matter. Now please listen. If I have something like this, CH3, CH, CH3, and I have Br on this middle carbon atom plus sodium in the presence of dry ether. Now please don't write anything. Listen to me very carefully. You are going to write the same thing, CH3, CH, and you will write Br here, and then CH3. Then you will attach these two carbon atoms. And bromine will be gone with sodium. You will attach which carbon atom? The alpha carbon atom. You attach this alpha and this alpha. Okay? So please listen how you are going to write the product. CH3 bonded to CH, bonded to CH3. Then again same thing, CH3 bonded to CH, bonded to CH3. There will be a bond between carbon and carbon, alpha carbon, alpha carbon. All if you understood this, yes or no, please tell me. What's the reaction? Hafsa, Fia, Mariam Khatun, Mohammed Tarif, Prabha, Deborah.
Understood, sir. Sir, here no
Yes,
need
sir.
to double the Na. Sodium no need to write 2 times.
No, no need to write. In the textbook, it will be Na, 2 Na will be there, but I'm talking about the way to focus. Okay. So don't focus on 2 sodium. Focus on how to make the product. Please remember, they will only give you this much. Okay. You have to draw this part on your own. You have to draw this part on your own. Okay. Write this down. See how to make product. I'm also writing a line. Write the substrate. What is substrate? The organic part. Write the substrate without halogen twice. Also, one more thing, when I say without hydrogen, don't just remove the hydrogen from here and leave the bond. And also, you have to erase the bond. Please don't leave the bond. Please don't leave the bond. Many people do this mistake that when I say remove the hydrogen, they will write it like this. When I say remove the halogen, they will write it like this, CH, CH3, and they will put up a bond. The bond will also be removed. Got it, guys? Yes or no? You, all of you know, those who do this problem. Okay, tell me, understood? Yes or no?
Yes, sir, understood.
Only Fia does this, nobody else. Hafsa, Mariam Khatun, you guys don't do this. All of you, please tell me na, yes or no. Listen, when you have bond line structure, then you see how many carbons? 2 carbon atoms. You draw 2 carbon atoms. Once again, draw 2 carbon atoms. Identify the alpha. This is alpha here. So this will be alpha and this will be alpha. Make a bond between them. Okay. So you will have 2 carbon like this and make a bond. So in total, now you have how many carbon atoms? 1, 2, 3, 4. When you have 1, 2, 3, 4, then you will make a complete structure. 1, 2, 3, 4. This will be the. This is the proper structure, even though this also is fine. If you write this down, nobody is going to do it wrong. If you have something like this, draw it twice without the bromine. Where is the alpha carbon? This is the alpha carbon. This is the alpha carbon. Make a bond. When you are going to write it properly, please see how you are going to write this? 1, 2. Where is the more carbon atom? On the right side of the above. Above we have more carbon atoms. So you go above. 1, 2, 3. Right side or left side both are having same number of carbon atom. You can go anywhere. 4. So you write 1, 2, 3, 4. Then 1, 2, 3, 4. 1, 2. 2 has 1 carbon atom. See, 3 has 1 carbon atom here. Even if you make this product, it's going to be fine. Make this product, guys. Send the answer on my WhatsApp. Giving you guys 2 minutes. If you're writing any other question, don't write. Write the third one. Write the third one. Send the answer on my WhatsApp. Make it twice without the halogen atom and join the alpha carbons. That's it. I don't need this product. I don't need this one. I need this. Even if you know what is the product, don't write that. I need this one. I will not accept this type of product. I need to see the working, okay? I need to see the working. How you have drawn 2 and then attached the carbon-carbon. Very good. Khatun, you understood it, right? Yes or no? Please tell me. Okay. Draw one more. Yes, very good, Hafsa. Very good. One, two, three, 1, 2, 3. Yeah. Fia, 1, 2, 3, 1, 2, 3. Yes, Fia, very good. Correct. Try the next one. 1, 2, 3. Those who are not sending the answer, I have stopped asking for answers from now on. I'll not ask for answers. Those who are not sending. Deborah, third one is wrong. Fourth one is correct. What is the okay? Deborah, you rewatch the lectures on. You rewatch the lectures on how to identify number of carbon atoms, how to identify number of hydrogen atoms. Okay. Look at in the third question, you have a mistake in counting the number of carbon atoms. Please see what is the mistake. Yes, Mariam, correct. Very good. Although the numbering is not right. Okay, Mariam, don't number it. Right now, don't number it. Numbering is not right. If you see, you will get more carbon atom if you start from the right side. 1, 2, 3. And then in the third carbon, there will be branching. You will go up 4, 5, 6. Okay. I will wait 1 more minute. I will give 1 more question. And then I will write the answers. Not this, not this. Br is here and we have a CH3 here. Sodium and bromide. Waiting 2 more minutes and then I'll write the answers for all the questions. Deborah, you correct the mistake in the third one. Number of carbon atom is wrong. Yeah. Yeah, that is correct. Fourth is correct. I don't know about the OR structure. OR structure 1, 2, 3, 4. Fia OR structure is not. Don't write the OR structure. No, I told you, no. Don't write the OR structure.
Okay, sir. But is that structure correct?
No, it is not correct.
It is 5 only, right, sir?
No, how it is 5? You are starting from the wrong carbon atom, no? And also, fine, it is 5. Then in the second carbon, what is the branch? The branch is having how many carbons? Tell me. You started with 1, 2, right? And then in the second carbon, the branch is having how many? It is ethyl branch, no? So that is
Yes,
wrong. That's
sir.
not right. Oh, wait a second. Yeah, this is right, Hafsa, but this CS3 you have not drawn here in the reactant. Reactant there will be CS3, no? You did not draw that. In the presence of not BR,
Yes,
my
sir.
bad. I don't know why I write BR. It is DE, right? Please correct if you're writing BR, it's not BR, my bad. Okay, my mistake. DE will be there, dry ether. Mariam. Oh, no. Mariam, not right now. Mariam, not right. Try once again, Mariam. Quickly try once again. You have to join the alpha carbons. Now, see, Mariam, you're doing this mistake always. Alpha carbon is not this carbon. This is not alpha. The most important carbon is this carbon atom. That is alpha. The carbon that is attached with halogen atom, that is alpha carbon. So in this structure, we have 1, 2, and 3 carbon atom. This is my alpha carbon atom. I will write 1, 2, 3, 1, 2, 3, and attach both of these. Now I will remember 1, 2, 3, 4, 5, and 6. So I can write this as 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Now when I look at the fourth one, I will have 1, 2, 3, 4 carbon atoms. This is my alpha. So I will make 1, 2, 3, 4, and 1, 2, 3, 4. Then I will join these two. Now, when I'm numbering, I will start from the larger number of carbon atoms. So here we have more 1, 2, 3, 4, 5, and 6. So if the structure is going to be 1, 2, 3, 4, 5, 6. Now, 1, 2, second carbon atom is not having anything. Third carbon atom is having CS3. Fourth carbon atom, see here. Third carbon atom, CS3. Fourth carbon atom, CS3. The CS3 and CS3 will be in the third and fourth carbon atoms. Now, when I look at the fifth carbon atoms, then I have here, this is my alpha. So I will write 1, 2 like this, and then I will write like this. And then I will attach these two carbon atoms. This is my alpha, and this is my alpha. Now, when I number it 1, 2, 3, 4, 5, and 6, I will get 6, 1, 2, 3, 4, 5, 6, right? So second carbon atom having CS3 group, and then the fifth carbon atom, 1, 2, 3, 4, 5. Fifth carbon atom is having a CS3 group. This is the groups here. Okay. So important thing is that you make this product right. Okay. If you're doing this wrong, it's going to be completely wrong. Chali, write this down. Those who have not done. Mariam Khatun, you corrected your mistake now?
Yes, sir.
No. You have not corrected it correctly now. Try it once again. Write it how I have written. Fia. Yeah, Fia correct. Very good. It's fine.
Sir, is numbering important?
No, numbering is not important. Now I am doing the numbering to make this structure. Okay.
Okay, sir.
If you leave the structures like this without numbers, it is not going to do anything. Numbering I am doing only to draw the, good looking structure. It's this structure, they don't look good, but they are correct structures. Okay. So the chemist in me cannot leave the structures like this. So I have to write it like this. No, I cannot leave it like this. My heart doesn't allow it to keep it like this. But These structures you can write. You are not a chemist right now. You're just a student who are studying chemistry. Okay. So you can write it like this. It's correct.
Okay, sir.
Yes, Mariam, now it is fine. Moving on, fatigue reaction, right? B part. Fatigue reaction is very easy. We take a haloarine. Halogen atom. Plus we take an alkyl halide, RX. We treat this in the presence of sodium and dry ether. We will get alkyl benzene. This R group will be attached on benzene. Okay. So we have haloarine. This is haloalkene. This is alkyl benzene. For example, if you have chlorine plus CH3 Cl, sodium in the presence of dry ether, this benzene and CH3 will be attached like this. And if you have, let us suppose, something like this, having Br here, having Br here, the presence of sodium and dry ether, this, so this carbon will be attached on this carbon atom, right? So you can write it like this and then attach both of these carbon atoms. This will be isopropyl benzene. I hope this is not very tough. It's very easy reaction. अरे एक सेकंड गाइस, एक सेकंड, इसको वुड्स फिटिंग कर लीजिएगा तो प्लीज राइट दिस एज वुड्स फिटिंग. माय बैड. I wrote fatigue reaction. I did woods fatigue कर लीजिए. Then I will show fatigue reaction. All of these are example of woods fatigue. Right, next fatigue reaction, C part.
Sir, can you scroll up? Can you show the last example? Yes, sir, done.
Right, next fatigue reaction. In fatigue reaction, it's very easy. We have a haloarine. You treat this with sodium. In the presence of dry ether, you will get two benzene rings attached with each other. This is known as biphenyl or diphenyl. So being a bit specific, if you have chlorine, now this halogen atom is here or here, everything is same. All the carbon atoms are same. Halogen atom can be anywhere. You will get that's it. After that,
Sir,
write some
so
remarks.
all the reaction with metals triether will be present for all the metal reactions.
Can you repeat what you said, Fia?
For all the metal reactions, dry ether will be present, sir. For all the
For magnesium and sodium, yeah. Will be present.
sir, if it's two benzene are bonded means two number of benzene rings should be there, right?
Sorry,
Sir,
you say?
for diphenyl or biphenyl, there are two phenyl groups or two benzene groups. For the two benzene, we need to add, right? So we'll write two in front of the reactant.
You can write it like this. That's fine. But you don't need to write. Don't focus there, okay, Fia? Don't focus on the balancing of reaction in organic chemistry. Okay, Fia?
Okay, sir.
Because it is going to take some of your attention, no? And you can use that attention somewhere else. Okay.
Yes, sir.
Wherever something is important, no? I will tell you specifically. For example, I don't tell anyone to remember. For example, I'm not writing here NaX also, right? I'm not writing here NaCl. Because that doesn't matter here. Okay, so keeping focus. And see, when that mattered, for example, it mattered where? In alcohols, it mattered, right? Final chloride, see? So when it mattered, I wrote everything that these are gas, these are gas, these are solid. Okay. So when it is going to matter, I will write it specifically. Okay. Okay. Moving on, please write some remarks. Number 1. Wood's reaction is not done with two different alkyl halides. With two different alkyl halides. Why? Because it gives mixture of product, mixture of alkenes, mixture of alkenes, difficult to separate. Okay, that is why. For example, if I take CH3Br, one haloalkene, and I take CH3, CH2Br, another haloalkene, I treat this with sodium and dry ether. Now leave your pen aside and please listen to me very carefully. All the methyl bromide, we have methyl bromide and this is ethyl bromide. Methyl bromide and ethyl bromide. Now in the solution, when I am keeping methyl bromide and ethyl bromide, there will be some methyl bromide which will come into contact with each other. They will react with each other. In the presence of sodium and dry ether, they will get CH3. There will be some ethyl bromide which will come into contact with ethyl bromide, react with each other in the presence of sodium and dry ether, give you, sorry, this is CH3, CH2, CH2, and CH3. There will be some ethyl bromide which will come into contact with methyl bromide and they will react with each other, leading to formation of CH3, CH2, CH3. So here we are getting ethane, butane, and propane. Now all of these will be having similar molar masses. That is why we cannot separate them. And since we are not able to separate them, that means we did not get any good product. That is why it is not done. That is why it is not done with two different alkyl halides. After this, you will write next point. Wood's reaction is not shown by tertiary haloalkanes as they undergo elimination and forms alkenes. So if I have CH3, carbon with CH3, carbon with CH3, and bromine, or any other halogen atom for that matter, in the presence of NaX, this is going to show elimination reaction, and we will get CH3 bonded to carbon, the CH3 as it is, and then there will be a double bond with CH2. Lastly, see the mechanism here. So first of all, we have sodium. When we have two sodiums, these two sodium, they are going to give two Na positive and they will give two electrons. Then we have RX haloalkene, delta positive in halogen, delta positive in carbon and delta negative in halogen, plus we will have two electron. Now this two electron will attack on R and they will give you R negative plus X negative, because electron is going, see here we have 2 minus charge, here also 1 minus 1 minus 2 minus charge. Okay, so the charges are balanced. So 2 electron on R negative. Now we have R negative. This R negative reacts with Rx, and this R negative attacks here because R is having delta positive charge and X is having delta negative charge. Now this R and R, they will form bond, plus you will get X negative. So we have got X negative here, we have got X negative here. One X negative will react with one sodium and then another will another sodium positive, you will get NaX. Please write the mechanism. Mechanism of Wood's reaction. Mechanism of Wood's reaction. Done now. Madam Khatun, you are saying done.
Done, sir.
Khatun, I can't hear you. Can anyone hear Khatun what she is saying? Fia?
No, sir, it's in a low volume.
Mariam, can you please write what you're saying? I don't understand what you're saying. I can't hear also.